Alrighty, so we're going to be solving systems of equations by elimination. Our objective here is to solve systems of two linear equations with two variables using elimination. And I want y'all to ask yourselves this. How does this method differ from the other methods? Okay, so there's different reasons why we use certain methods, and you're kind of going to get to pick which one you like. So the idea here is you're going to be combining the two equations to get one equation with only one variable. So you're going to take two and be able to combine them so that you only have one variable up. Now, to be able to do this, you need one variable. They have to have opposites, like opposite coefficients. And so you'll kind of see the examples there. If they aren't opposites, you kind of have to make it happen. And again, I'll show you those with some examples. So the first example we're going to do is 4x plus 6y equals 32, and 3x minus 6y equals 3. Now, if you notice here, the y's are opposite. You got a positive 6 and a negative 6. So since those two are already opposite, I can go ahead and say I'm going to combine the two equations. And it's like the way you did elementary school addition subtraction. 4 plus 3 is 7x. The y's cancel each other out. They're gone. And 32 plus 3 is 35. So right now, you've now combined the two equations, you're down to 1. And all you got to do is divide to get your answer. 35 divided by 7 is 5, so x equals 5. Now, from there, you need to find your y. So the second one takes a little bit more work, but you can choose either equation. What I'm going to do is I'm going to put the 5 in place of the x on the top equation. So I'm going to say 4 times 5 plus 6y equals 32. 4 times 5 is 20, plus 6y equals 32. Then I need to subtract, and then I can divide to get y is equal to 2. So my answer is 5, 2. So notice, what we first did was we eliminated the y's and combined the x's. Then we divided to find out what x was. We took that answer and put it into one of the equations. My choice for this one was the top one. So I said 4 times 5, and then we solved it. It becomes like solving a normal equation. So you multiply, add or subtract, and then you can divide. So let's look at another example. Here, I've got the x's are opposite. Notice that it's positive 3x, or negative 3x, and positive 3x. So the x's are going to cancel, and I'm going to combine the y's. So 7 plus 5 is 12y. Negative 11 minus 1 is negative 12. And the x is canceled, and then I can divide to get negative 12. So y is equal to negative 1. Now again, I can choose either equation I want to. This time I'm going to choose the bottom one. So I'm going to say 3 times negative 1, 3x plus 7 times negative 1 equals negative 1, because I'm putting the negative 1, this negative 1, in place of the y. And then again, you're going to multiply, add or subtract, and then you can divide. So again, all I've done there is plug in, first eliminate it, and then try to plug into one of the two equations. So what happens when the numbers are not opposites? So if you look at this example, you notice here it says 5r plus 2t equals 6, 9r plus 2t equals 22. A big mistake people make is they'll automatically just cancel out the t's and say 5 plus 9 is 14. You're already messing up if you do that, because right now the t's are not opposite. They're both positive, so one of them has to be negative. It really doesn't matter which one you make negative. I usually like to say I'll make the bottom one negative, but again, it does not matter. But if you're going to make that one negative, you need to make the whole thing negative. Or you need to change the sign of everything. So not just am I going to change the sign of the 2t, so I'm going to change the sign, not of just the 2t, I'm going to change the sign of the whole equation. So instead of saying positive 9r, negative 9r, minus 2t equals negative 22. Now the t's will cancel, and I can say 5 minus 9 is negative 4, 6 minus 22 is negative 16, and I can divide to get r is equal to positive 4. And again, it does not matter which equation I want to put this into. I'm going to go ahead and put it into the bottom one, because notice how I've kind of spaced it, and I've got the space there. So 9 times 4 plus 2t equals 22. Notice I did it into the original, the way it was written. I multiply, then I can subtract, and then divide, and I'll have my answer. Okay, so there you go, and that would be your final answer there. Again, the main point here is they have to be opposites, and they have to be one positive, one negative, and they have to be the same. They have to be the same number, opposites. Okay, so let's look at the next example. Okay, here I have 9x minus 2y equals negative 8, negative 7x plus 3y equals 12. Now notice here, they're not, I see that the x's and the y's have opposite signs, but they're not the same numbers. So in this case, you can choose which one you want to get rid of. But you can't just get rid of them. You have to make sure they're the same number. So how can I do that? The easiest and surefire way that will always work is pick the variable you want to get rid of and then switch the numbers. So in this case, I want to get rid of the y's just because I feel like it. I want to get rid of the y's. So I'm going to do, I'm going to put parentheses around everything, and I'm going to switch them. So I'm going to multiply the top equation by 3 and the bottom one by 2. So now I'm going to say 3 times 9 is 27x, 3 times negative 2 is negative 6y, and 3 times negative 8 is negative 24. 2 times negative 7 is negative 14, 2 times 3 is 6, and 2 times 12 is 24. Now I only did this, notice that I multiplied by positive numbers because they were already different signs. So since they were different signs, the numbers that I multiplied by were positive. Okay, so now my y's will cancel. Notice that the numbers equal 0, divide by 0, and you'll get 0. Plug that into the x, since it was x equals 0, and again I can solve. Notice I'm putting this one into the bottom one just because, it's convenient. So again, you see how the steps go, and you can kind of follow along with those steps. Okay, here's another example. I am doing quite a few examples because I'm trying to show you every little bit that you can do here. On this one, I've got 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. Now, some other teachers might tell you, again, there is a different way you could possibly do this. But what I'm going to tell you is I'm just going to stick to exactly what I say. It's my foolproof method. I'm going to say I want to get rid of the y's, and so I'm going to switch the y numbers. So I switched them. Notice the 3 that was on the bottom is multiplying the top equation. The 6 that's on top multiplies the bottom equation. But since they're both positive, one of them has to become a negative. And it doesn't matter which one. I usually just choose the bottom one. So then I'm going to multiply all the way across. So I'm distributing. And then I can go ahead, cancel out my y's. 15 minus 12x was 3x. Negative 24 plus 30, because that's a positive 30, is 6. And then I can divide by 3 to get 2. Plug that in. Notice how I'm putting it again into the, it doesn't again matter which equation. I'm just choosing the bottom because that one's easier for me. And notice again the steps that I'm doing: multiply, add or subtract, and then divide. So the steps again stay the same. The more you practice with this, the easier it gets. Alright, so I believe one more example. Let me double check. Okay, so there's my last example. Again, notice I have positive x's but negative y's. It does not matter which one. Let's say I want to get rid of the y's. So I'm going to switch the 7 and the 2. Usually, for some reason, I get rid of the y's in elimination, but I don't know. It's just something I do. But again, since they're the same sign, one of them has to multiply by a negative. So that way, I'll make sure I have different signs. So 7 times 6 is 42x. 7 times negative 2 is negative 14y. 7 times 10 is 70. Negative 2 times 3 is negative 6x. Negative 2 times negative 7 is positive 14y. And negative 2 times 19 is positive 38. Combine and eliminate. Then you can divide. And you will get that answer, x equals 3. Plug that into one of the equations. Multiply, add or subtract, and then you can divide to get your final answer of y equals positive 4. So x equals 3 and y equals positive 4. And that's pretty much it. That's all you got to do. So I think got to go back and listen to the other video. But You can probably hear, maybe, I don't know, in the background, say a swim coach yelling because, well, that's what swim coaches do, I guess. Anyways, let's see here. If you show me, and maybe I'll add some points somewhere, I'll decide how. Write down on your paper my favorite Christmas song, which is Little Drummer Boy. Write that at the end of your notes and just make note of that quietly to me. Right? My favorite song again is Little Drummer Boy. So write that onto your notes and I'll add that in if you show it to me at the end. Thank you very much. Have a good day, and thank you for listening and watching.